So part B of the 2022 plane geometry question: to determine the dihedral angle between the plane ABC and ABD. Okay, so here is ABC in plan and there's ABD in plan. AB is the line of intersection between these two planes. What you could do, if you have an adjustable set square, by all means use it here. It'll speed you up a little. It's not the end of the world if you don't. So you could set up your adjustable set square to this angle and bring out all of the points perpendicular to the line AB. So I'm just I'll use yellow color for this. So I'm going to bring D out. I'm going to, just before I do it, I'm just going to mark in my X1, Y1 line. So as I can see where the lines are coming from. So as I'm marking this out, I know my heights are going to be marked from 2 views back. So 1 view, so D is the biggest height. So that's why I've done considerably long line for D. B, I don't have to go out too far. So I'll go out about that much with my construction for B. A is going to be even shorter again, so that's enough. And C, all I have to do is bring C out to the X1, Y1 line. Okay, so immediately I have the height for C, and again, I'll explain why. So I'll just mark in my X1, Y1 line. So if I want a distance for these lines, I go back 1 view, 2 views. The height for C is 0. For A, I go back 1 view, 2 views. The height for A is 40 millimeters in elevation. So I'm going to mark 40 millimeters for point A. For B, 1 view, 2 views. The height for B is 80. And then finally, D, the height for D is 105. So I go back 1 view, 2 views, 105 millimeters for D. I'm not bothering with E, F, or G because we weren't asked for it. So the plane ABC will look like such. So A, B to C. And A, B to D. I don't mind, I'm not concerned about hidden detail here at all. Okay, and what I want from there is to know that AB is a true length. Because I projected perpendicular to AB, this is a true length of the line AB. Okay, so moving on now, I can choose for my dihedral angle to either project it upwards in line with the line AB here, or down in line with the AB here. So I'm going to choose to do it down here. Keep it nice and tight as possible. So again, setting my adjustable set square to the line of the true length. And I'm going to project out the line AB. C and D. Perpendicular to that, I'm just going to set my X2, Y2 line. And take my distances from 1 view, 2 views back. Now, this is a big waste of space here, so I don't want to take this. So I'm going to draw a datum line. Okay. Now, it's important to note here that the datum line must be parallel to the line that you should be taking the distance from, which is the X1, Y1 line. So I'm going to go back here, and okay, I'm actually going to go back to touch perfectly in line with AB. So I'm just going to draw a dotted line here. Okay, and I'll just label in datum. In fact, I'll write that clearly in black so you can read that. D-A-T-U-M. And I always like to label it, it's a datum for the X2, Y2 auxiliary, for the X2, Y2. Okay, so A and B are on the datum line, therefore A and B have a height of 0. A, comma, B. Right, for C, I'm going to go back 1 view, 2 views. So this is the distance I'm going to use for C. So with my compass here, just going to record the distance from C to the datum line and apply it on the appropriate line. So that's C and D. So here's the D line, take that distance and apply it. D. So ABD is an edge view of one plane, ABC is the edge view of the other plane. So that is the dihedral angle between those two planes. So I just always like to draw an arc between the two of them. And I'm going to mark that in as theta and sharp arrowhead on my arc. 4mm block capital text. And I'll just say theta equals dihedral angle. And that's part B. Okay, done.